Hi, this is Esther, and I'm here to help you pass the Cloud Digital Leader exam by Google Cloud. Let's talk about why cloud. Why cloud? Alright, so first, to understand what's cloud, let's talk about data on-premise. Alright, so as you can see in the left, there are a lot of servers, alright? And these are my servers that I own in my organization, and I use them to hold customer data, all right? Customer data. Okay. I think my pen isn't working, so I just won't draw for now. So I use this to store customer data. And for example, all right, now I have 100 customers. So I only need one server, let's say for example. But suddenly, okay, I went big and a lot of people wants to use my website now. I used to be a small business with 100 people using my website. Now a lot of people want to use my website. So I bought one more server here and now I'm waiting for it to come. But while I'm waiting for it to come, I only can hold 100 customers' data. So it's very hard for me to scale. Now, let's say now it's Christmas period, right? Suddenly a lot of people want to use my website to buy Christmas gifts for their family member. So I buy a few more servers to accommodate that, right? I buy 2 more servers, right? Okay, so now Christmas period is gone. Christmas period is gone. These 2 servers here are in idle. There's nothing there. There's nothing there because basically it's money sitting there and not being utilized. It's such a waste of money because I don't actually need that much space at that time. So now you can see the problem with owning your own asset, right? Having your own servers and buying all the servers and owning it, it's quite problematic. And is worse about this is that you have to pay for staff, right? These servers don't just run on their own. You need air conditioning to cool them down, right? You need to get a man or a woman to like take care of all these servers and maintain them, right? If you own them, you have to configure them, you're responsible for everything about them, and it's not scalable. For example, if my customer size suddenly grows, right, I need to buy new servers and I need to wait for them to arrive. That takes time. That takes time. That takes time and that takes money. And hiring this guy takes money, right? Buying these servers takes money. And having idle servers that I'm not using it is really wasteful. That's why people are moving to the cloud platforms such as Google Cloud, right? So let's kind of compare what's the difference between on-premise and public cloud, okay? On-premise versus Google Cloud, all right? So going on Google Cloud is like renting. Instead of buying a server, you rent other people's infrastructure, other people's server. So you don't have to hire somebody to maintain it because it's owned by Google. Google hires people to maintain it. So it's kind of like renting versus owning, right? If you use public cloud or Google Cloud, you're like renting. You're renting a room, right? But let's say you have your own on-premise, you're kind of owning. So you spend a lot of money building the house, right? You build the house. You spend a lot of money buying the servers, which are not scalable at all, right? And then you also have to hire people. So we move to the public cloud. We move to operational expenditure because you're paying either a monthly fee based on a contract or whatever it is, all right? So that's how you see it. So on-premise, you spend way more money than if you rent, right? I mean, We all know that if you buy your own house, it's more expensive than renting a house, right? It's that concept. Buying versus renting. It's cheaper to rent. If you don't want to live there anymore, you pack your bag and move. But if you buy a house, you have to take care of those assets. That's capital expenditure. Okay? So what is the benefits of a cloud? First of all, it's scalable. This picture illustrates scalability very well. So it grows. If it's during Christmas period or a New Year shopping period, right? Or start of school year, kids are buying school supplies, and a lot of people are on your website buying school supplies like Amazon.com. You can scale, right? Because Google has all these servers all around the world in different regions and zones, right? So you can just use their infrastructure and scale. You don't have to buy server and then they take time to come, right? That's a lot of money. And after the shopping season is over, right? You have idle servers that's sitting there doing nothing that costs thousands and thousands of dollars, right? So that's scalability. That's the benefit. The other is you pay as much as you only pay as much as you use. But that's the difference from on-premise. You gotta buy your stuff, right? You could be paying for things you're not even using. Okay, that's the difference. Abstraction is you don't have to worry about the finer details. Abstraction. For example, a good example of abstraction is this vending machine. You don't have to understand how this vending machine, but you just need to know how to press the buttons. You just need to know, okay, I want Coke, press Coke. Okay, now I gotta put my cash in. All right, I put my cash in. Okay, I just need to press this button, then the Coke gonna drop right down out. Right? That's all you need to know. You don't have to know the intricate details of how the vending machine works in order to use it. You don't have to know those intricate details. Abstraction is don't have to worry about the finer details. And for Google Cloud, you have encryption, right? It's automatic encryption on transit and at rest. You have security. These public cloud infrastructure, right? Google have a lot of security guards and cameras and all that kind of stuff. They don't just let anybody go in like a playground, okay? It's highly secure, okay? And lower total cost of ownership, or TCL. Alert, this will come out in your exam. It's very, very important. Total cost of ownership. Why is it lower? You don't have to buy servers. Okay, you don't have to hire a guy to maintain all your servers in your company. So on-premise, you're buying servers for yourself. You own it, right? Owning versus renting. Remember, owning your own house and building it from scratch, it's a lot of work. It's more expensive. Renting is cheaper. All right, so lower total cost of ownership, and that's the benefit of public cloud. Now let's go down and look at the different types of public cloud that it's available, right? There's Azure, there's AWS, there's Google Cloud, there's Naver Cloud, there's IBM Cloud, there's even a Huawei Cloud, and on and on and on. I can go on. There's a lot. But the big three are Azure, AWS, Google. So if you want to learn, forget about the rest. Focus on Azure, AWS, Google. Most people use AWS, okay? In certain countries, they only use Azure. So depending on where you live, pick your focus. Now, the other concept, alert, that will definitely come out in the exam is the concept of multi-cloud and hybrid cloud, which I will explain to you simply. Multi-cloud is when you use more than one public cloud. Okay, so for example, Esther's company decides to use Google Cloud plus AWS. If I use these two, I am a multi-cloud, right? If I only use Google Cloud, no, I'm not multi-cloud. I'm not multi-cloud. If I use only Azure, sorry, I'm not multi-cloud. I have to use more than one public cloud in order to be multi-cloud. So I have to use more than one of these. One of these public cloud service, either Azure, AWS, Google Cloud, Native Cloud. Yeah. What's hybrid cloud? Hybrid cloud is when you use public cloud plus private cloud / on-premise. Okay? So for example, I own and rent at the same time. Basically, you can think of it like that. I'm owning and renting at the same time. That's hybrid cloud. For example, I have my own servers and infrastructure in my own company on-premise. And I'm also a customer of Google. That makes me a hybrid cloud. All right? So this will definitely be tested. Make sure you understand it. All right? So another concept that you have to understand for the exam is regions and zones. So if you look here, these are the regions that Google has: Sydney, Melbourne, Jakarta, Singapore. And the ones with the circle blue dot are current regions with 3 zones. So zones is like a place, and regions is like a place too. But the zones is inside the region. All right? So Google has 40 regions, 121 zones, 121 zones, 187 network edge locations, and 200 plus countries and territories. So if you look at here, Melbourne, Australia, APAC is a region. It's a region. And inside this region, Melbourne, there are 3 zones: A, B, C. Australia Southeast to A, B, C. So using Australia as an example, okay, using Australia as an example, this is a region. Okay, this is a region, and these zones are inside this region. Okay, so this is zone 1, zone 2, zone 3. Okay, so this is the data center in zone 1. This is the data center in zone 2. This is the data center in zone 3. Okay. Now, let's say an alien comes and this alien takes this zone away. What happens? My data in zone 1 is all gone. It's all gone. So, in order to protect my data, what I should do is I should put my data here and here. Okay? So I should replicate my data in both of these 2 zones, or even if I can replicate it to the 3rd zone, it'll be even better. So in that case, if an alien takes away this data center, at least my data is still here, right? And here. But let's say if the alien comes and the alien takes away my data, also here and here. So what happened? My data is gone. My data is gone forever, right? It went to alien land. So what I should do is perhaps I can put my data in a different region. For example, Warsaw, Poland. Okay? Then I could put in the data center here, right? So if the alien comes and takes away the data center here, takes away the data center here, takes away the data center here, at least I still have my data in Warsaw, Poland, and I can still function as an organization, right? And so this is talking about, if I'm protecting myself from zonal failures, I'm being zone failures, okay? But I also should protect myself from regional failures. So what if the whole of Melbourne fails, right? So that's the things that business need to think about, because now I'm using alien as an example, but in real life and world, right? Sometimes there are wars, sometimes there's fire, and, sad things happen. So we need to be prepared, and we need to continue as a business to have disaster recovery plans. Okay, so now you really love the cloud and you want to migrate to the cloud, just like birds are migrating to another country during the summer or the winter. So there are many ways to migrate to the cloud, right? First, you can either rehost. So when you rehost, this is the minimal time and effort, right? You don't have to use much time and effort, but then you reap very little business value from it. Then the other approach is re-platform. For this, you have to use more time and effort, but then you reap more business value, which is the diamond. Okay? So this is the rehost, re-platform, refactor, and reimagine. And RIP is like the system died. You're not going to use it already. It's RIP, rest in peace. Okay, you rip and replace. This is something you definitely have to remember in the exam. It will definitely be tested, and it's under the category of migration. All right, and then if the exam question says, I don't have a lot of time and I don't have a lot of IT staff, then you shouldn't be picking refactor as the answer or reimagine as the answer, because the answer should be rehost, lift, and shift, because the rehost, lift, and shift takes the least amount of time. All right, so take note of that during the exam. But the problem with rehost, lift, and shift is that you can see that it doesn't have a lot of value, right? It doesn't take full advantage of the cloud. So for example, if you're using SQL on premise, you just move to cloud SQL. You're basically using the similar service, right, from on-premise to cloud. Now, when you refactor, you actually change the code. That's why it takes more time and more effort, but you reap more benefits of the cloud. All right? Reimagine is more like the strategy, the vision of things. All right? And when you reimagine things, you benefit most from the cloud. You benefit most from the cloud. All right? So when you rehost, which is basically lift and shift, you transfer with no modification. You don't change anything at all. And this is good for a legacy application. When you re-platform, you have minimal changes, so you don't change the architecture. You don't change the architecture, okay? And when you refactor, you actually change the architecture. That is the difference, okay, between these two. And when you refactor, you rewrite the code. Rewrite the code where needed. And when you reimagine, it's about the cloud strategy. Okay, you think of ideas, okay, what will my cloud be like in the future? Should I use AI? Should I use more of this? So that I can give more business value to my business. All right? So to end off and review, the migration types are rehost, which is lift and shift. Minimal effort. You don't spend that much time on it, but not that much business value. Okay? Re-platform. You're not changing the architecture yet. You don't spend that much time yet. And then there's more business value. When you refactor, you change the code. So you go on to the computer like this guy over here, and you actually change the code. That takes time, right? So you'll have more time used, but you'll reap more business value. Now for reimagine, it's the strategy part. All right. Rip and replace. The name is quite obvious. You're saying bye-bye to it. You don't want to use it anymore. All right. Remember to memorize this for the exam and you'll do well. Migration to the cloud. Think of it like moving services. So you're moving from one home to another home and you need people to help you move your things. Yeah, think of that. For example, you're moving from your on-premise data center to Google Cloud. Then you need to call moving service to move all your things there, don't you? Right? So just imagine this as a moving service. These guys are helping you move all your stuff to Google Cloud. So database migration service is these movers helping you move your relational database migration to Google Cloud. So this includes MySQL, PostgreSQL, SQL Server, and Oracle database. So what are relational database? Relational database are like, think of it like human. Human, we have relationship, right? We have mother, grandmother, grandfather, and things like that. So relational database could be, this is cars. Yeah, this database is cars. Then the other database that connect to it could be like Ferrari or Jeep or like Mercedes, right? Their relationship, they have relationship to each other. They're relational, okay? That's why we call it relational database, and it's very structured. There's a fixed format you have to follow. The other way to transfer is you literally put it in this box. You put your data in here, and Google gets it and they bring it to their data center and they transfer the data. You only do this when you have too much data that you need a physical drive migration. Some customers just cannot do online transfer. So they say, get this service, and this is a tamper-resistant ruggedized case, and they put their data inside of this case. And this case goes to Google Data Center. All right, so this is a very interesting way of transferring data in certain situations. The other way of transferring to Google Cloud is storage transfer service. Storage transfer service automates the transfer of data to, from, and between object and file storage systems, including Google Cloud Storage, Amazon S3, Azure Storage, on-premise data, and more. So it's multi-cloud. You can multi-cloud. Remember what multi-cloud means? Multi-cloud means more than one public cloud, right? So I can do with more than one public cloud. I can do with AWS, I can do with Azure, right? And this stands for on-premise, this one. Okay? And you don't have to be worried because data is encrypted. What does data is encrypted mean? So for example, my data is 1, 2, 3, for instance. Then I don't want anybody to know my data is 1, 2, 3. For example, it's my super secret password is 1, 2, 3, and I cannot let anybody see that. All right? So it has to be encrypted. So let's say somebody goes into my company and steals my data. If my data is encrypted, instead of saying 1, 2, 3, actually, this is what they see. If it's encrypted, maybe they see like X, Y, 1, 2, A, and however. Do you see some weird character that's not even closely related to 1, 2, 3? So it's encrypted in that sense. All right. The other option is Cloud Interconnect. Cloud Interconnect. Cloud Interconnect is a direct physical connection between your on-premise network to Google Cloud Platform, short form GCP. All right? So there's two options when you want to use Cloud Interconnect. Option 1, dedicated interconnect. Option 2, partner interconnect. So what is the difference between dedicated interconnect and partner interconnect? The difference is, for dedicated, you go to a co-location facility. While partner interconnect, you go to Google's third party. So what it happens is that you have a direct physical connection from your on-premise data center, and the data flows here. It flows to the co-location facility, then it flows to Google Cloud data center. Okay, it flows in that way through a lot of wires and stuff like that. Okay. Now, for Partner Connect, data starts from on-premise, then it flows to the partner, then it flows to Google Cloud. All right? So, note, usually people only use third party when they cannot access a co-facility. They usually only use a third party when they cannot access a co-location facility. So having co-location facility is definitely the best option. Pick that. So what is a co-location facility? A co-location facility is often referred to as a data center. It's a space where business can rent physical space to house their servers and other IT equipment. They have cooling systems, security, high internet speed, and more. Let's talk about the Google Resource Hierarchy. Google Resource Hierarchy. What's that? Now, it's how things are organized, just like your computer file, right? You could have a hierarchy of file. For example, your mother file is YouTube videos, and then you can have sub-files inside those files, right? So that's a hierarchy itself. So here, the level 4 hierarchy is org node. Org node. That's your organization node. Organization node. That's why I put this picture here. And within the organization, you could have different folders. That's level 3. You could have different folders. One folder for maybe like HR. Usually you might not do that like that, but just an example. Then you can have another folder for like business, and another folder for like management. Yeah, let's say. So you could have different folders to organize your stuff. And within those folders, you can have projects, different projects, not just one. You could put multiple projects inside, right? And within the projects, you could have resources, yeah, like buckets and storage, okay, or your spanner or your virtual machines, all the service, right? You can put it here, your Cloud SQL, things like that. All your resources you put in level 1, and that's how deep it gets. All right, here's the important part you need to know for the exam. Alert. Let's use this boy Sammy as an example. Okay, Sam. Let's say I gave Sammy access to this file. He will automatically have access to the projects inside the file and the resources inside the projects inside the file. So he has everything inside this file. All right. the access is inherited from the top levels, right? Now, if I says, Johnny, you cannot touch, let's say, this file, then Sam, if I tell Sam, if I put in my IAM that Sam cannot touch this file, then he cannot touch everything inside this file. Everything, okay? I hope that's clear, right? So it's org node, folders, projects, resources. Resources are inside projects. Projects are inside folders. Okay? So during the exam, they will ask you questions like, oh, I gave Sam access to this folder. Would he be able to access this project and this resource? Google Site Reliability Engineering SRE framework. 4 golden signals for monitoring the reliability of a service. Number 1, latency. Number 2, traffic. Number 3, errors. Number 4, saturation. And let's go one by one. First of all, traffic. Think of your traffic jam. If there's a lot of cars on the road, there's high traffic. If there's not a lot of cars on the road, there's low traffic, right? Okay. So it's the same for your website, your system, or whatever. If there's a lot of people accessing your system, then the demand of your system is high, right? High traffic. That's the demand of your system. Requests per second. So, for example, during Christmas, a lot of people will go to Amazon.com and buy gifts for their friends, right? Oh, I gotta buy a gift for Johnny. I gotta buy a gift for Sissy. I gotta buy a gift for Mama. So there will be high traffic during sales period. There will be high demand to go on Amazon, right? So it's how many requests that reach your system. All right. Now let's go on to saturation. What is saturation? Saturation is how full the service is. How much capacity left. As capacity is rich, performance will be degraded. Capacity of resources utilization like CPU, memory, and disk space. Let's imagine this is your... what happened? This is your CPU, okay? This is your max, okay? And you already used this much. So as you reach the max, your performance will be degraded. So this is something you gotta watch out for. Now, let's look at latency. What's latency? Think of latency as speed. Latency is how fast data travels, right? When we talk about bandwidth, we were talking about how much data could be carried within a certain period of time. Latency is how fast. Okay, this white guy, he's data, Mr. Data. Okay, Mr. Data. Mr. Data. Mr. Data is running. So how fast can Mr. Data run? And it's often measured in milliseconds, okay? High latency, by the way, it's bad. It's not a good thing. Low latency is good. High latency is something you wouldn't be happy with when you're gaming, right? It's super slow. Low latency is good. It's just like you're racing, right? Is it better if you take 1 hour to race something or you take like 5 seconds to race something? Of course, the lower the better, right? Okay, speed. Now, in the principle of latency, there's something called hop. Okay, so imagine this girl is hopping, right? Now, if Mr. Data had all these hops here, right, where he had to hop over, will he be faster or will he be slower? He'll be slower, right? So each hop increases latency. It'll slow him down. It'll slow Mr. Data down. All right? So a hop refers to the journey a data packet takes from one network to another, such as from one router to the next. Each hop introduces a small delay known as latency due to the time it takes from the router to process and forward the packet. Okay, to help you better understand, let's see this delivery man. Okay, he's carrying this data. Okay, delivery man is carrying data. And his ultimate destination is this house, okay? This house is your network device, all right? So imagine the other houses as other network devices that the delivery men have to stop by before they go to your house, which is the ultimate destination, okay? And you're playing games in this house, so you really want this delivery man to bring the data real fast, don't you? But the problem is, he has to go to this house first. Okay, that's one hop. Then he has to go to this house first. That's another hop, another network device. Then it reaches you. So it's slower. More hops, slower. All right, I think you get it by this point. What's a house? A house is a network device. All right? Now, down to the last one, error. What is error? I mean, you guys all know, right? Failed requests such as HTTP 500 errors or timeout system errors. All right, so to review, the Google cites reliability engineering SRE framework. 4 golden signals for monitoring the reliability of a service. Number 1, latency. Number 2, traffic. Number 3, errors. Number 4, saturation. All right. What is redundancy? Redundancy is having multiple instances of a critical component or system to ensure availability and reliability. Okay? So, for example, to help you understand, for example, I have a document. This is my homework for my teacher. So in order to prevent accident, let's say my dog ate my homework and this copy got destroyed. My dog ate it. I have no more homework to hand in to my teacher. What am I gonna do for class tomorrow? I'm in trouble. So here's the thing. This is where redundancy come in the picture. What I do is I make copies of my homework, right? Just in case my dogs eat it. I make copy 1 and 2 here. So it's like having multiple exam cheat sheet. So if you lose one, you'll still have backups to rely on. It's having multiple instances of critical components, replicating your critical components. So if one critical component goes down, right, at least you have the other 2 or the other 3 or 4 or whatever it is. It prevents downtime and data lost. So what is bandwidth? Bandwidth is how much data can travel in a given amount of time. How much data can travel in a given amount of time. So if your bandwidth is very low, you cannot download large files. Large file downloads require higher bandwidth to function smoothly, else it will not function smoothly. Your internet service provider will tell you the bandwidth of your internet, right? So higher the bandwidth, the more data you can download. So think of bandwidth like this. This guy is the delivery man, and he's carrying many boxes of data. If he has high bandwidth, he can carry more boxes of data. If he has low bandwidth, he can carry less packages of data. So what is this delivery man's bandwidth? Or in other words, how much data can this delivery man handle over the network connection? Now, bandwidth is often measured by bits per second, kilobits per second, megabits per second, or gigabits per second. This is the measurement of bandwidth. So again, bandwidth is how much data can travel in a given amount of time. And this will affect your download speed of large files. What are the Google observability? First, there's cloud logs. Cloud logs is where you store logs. I know. But what are logs? Think of logs as notes that keeps track of everything, when and what happened. This way, if something goes wrong, we can look at the logs to understand what happened and fix it. It's, for example, you writing down, okay, I changed my pants at 10 a.m. I brushed my teeth at 7 a.m. I went to school at 8 p.m., for example, things like that. And so if something goes wrong, you know exactly where it went wrong. For example, if you lost your pencil and you're like, okay, when did I take my pencil? Okay, that might be where it went wrong. So it's when and what. You can actually filter it based on the date. For example, if I only want to see things that happen on the 27th of July, I can look at that. If I only want to see things that happen at 9 a.m., I can look at that. All right? You go here when things go wrong and you want to know what time and where, what happened, you can search for it, filter and search for it. So what is cloud monitoring? Cloud monitoring is like, think of it like a dashboard with the overall health and you can set alerts with a dashboard. Yeah, dashboard here. Okay, what's cloud profile? Cloud profile is all about the CPU power and memory. In the exam, if you see like CPU power, memory, usually the answer is cloud profile. Cloud profile. All right. Next, cloud trace. Cloud trace is all about tracing what? Tracing latency. It's all about tracing latency. All right. You have reports about latency. You have API for tracing latency. Okay. Let's talk about the difference between horizontal scaling and vertical scaling. Okay. So vertical scaling is I have the server and I would increase the capacity of the server with CPU, RAM, or storage. So if this one server, right, I increase it. So I make the server more powerful. So imagine I have a pizza and I need to feed more friends. So what I do is I would make this pizza bigger so that I can feed more friends. Now for horizontal scaling, instead of making this pizza bigger, I would just buy more pizza of the same size, right? In order to feed my friends. So this is horizontal scaling. If I have this server, for example, this server is 3 gigabytes. Okay? Then I'll get 2 more of 3 gigabyte servers so that this pool of servers would distribute the load together. All right? So the difference is vertical scaling. It increases the capacity, the CPU, the RAM, and the storage of the server. So I'm making this bigger and better. That's vertical scaling. Horizontal scaling is I'm taking one server and I'm adding more of the servers. Horizontal scaling is more flexible and it can handle more traffic, but requires coordination between multiple servers. So you need to manage, you're adding pizza. You have more friends to feed, you add more pizza. You order more pizza. You order more large pizza. Here is, I have a medium-sized pizza, but I have so many friends coming, so I'll make it a XL size pizza instead, in order to feed my friends. That's the difference, okay? Okay, so now we're going to talk about the concept of infrastructure as a service, platform as a service, software as a system, software as a service, container as a service, and function as a service. Okay, so these are the different types of services that you can have in Google, right? So this row is the Google services. Then the second row is what you are responsible for. Then the third row is what Google manages, or in other words, what Google is responsible for. And the last one is the remarks that I wrote. Okay, first, infrastructure as a service. Infrastructure as a service includes services such as bare metal, engine, which or bring VM. You are responsible for the data and configuration, application code, scaling, runtime, and OS, which stands for operating system. But you don't have to be responsible for the virtualization and hardware, because Google takes care of the infrastructure and how the virtual machine functions and things like that. For platform as a service, it includes App Engine, Cloud Run. You are responsible for data configuration, application code, scaling, so you have to know how to code. Then Google is responsible for runtime, operating system, virtualization, and hardware. So for both infrastructure as a service and platform as a service, know how to code. Especially infrastructure as a service, right? You need like a lot of good IT staff who know their stuff well. Software as a service is good for people who are not very technical. They don't really code. So Google services are like Gmail, Workspace, Google Workspace, like Google Doc, Google Drive. All these are software as a system, and it's very common in the internet. Salesforce, for example, Monday.com, ServiceNow. These are all software as a service. You probably use the software as a service before. For Outlook, these are all software as a service. What are you responsible for? Your data and configuration. On Gmail, I don't have to code, but I'm responsible for my settings. I'm responsible for my contacts. I'm responsible for whatever data I put in, right? Well, Google manages the application code, the scaling, the runtime, the OS, and virtualization hardware. These are the things. So for software as a system, you don't really manage a lot of things, right? It's the easiest. You don't have to code too. Now moving on to container as a service. It includes VKE and Cloud Run. What are you responsible for? You're responsible for the data and configuration, application code, scaling, and runtime. Google manages the operating system, virtualization, hardware. And you have to code for this. For function as a service, there's Cloud Run functions. It was previously Cloud Functions, now Cloud Run functions. So they put it inside Cloud Run. You're responsible for the data and configuration and application code. Google manages the scaling, runtime, operating system, virtualization, hardware. And you have to code because Cloud Function is easy, but what happens here is that there is a trigger, and this trigger, this event, it could be you deleting something or you adding something to storage. This is an example, but there are many other possibilities. So this trigger of you deleting something or adding something will lead to a small piece of code being run, right? And it does something. So this is what we call function as a service.
Let's talk about sustainability of Google data centers. First one, Google data center is 24/7 carbon-free energy by 2030, okay? Google has been carbon neutral since 2007 and continues to invest in carbon offset projects. And it's designed to be highly energy efficient, and it just cares for the environment, the turtles, the bird, and it just loves nature and reducing carbon emission. Okay, and here's the important part. Tip. For MCQ questions about how do your company be more sustainable, the answer is usually choose Google data centers to help organizations meet their sustainability target. All right. Every company would want to promote themselves, right? So the answer is always should be Google Cloud. How to save money on Google? Discounts. Let's talk about how to save money on Google. Yeah, we all want to save money, don't we? So how? First, there's sustained use discount and commit use discount. Committed use discount is like, okay, Google, I promise you I'm gonna use your service for 1 to 3 years. So you get a 1 to 3 year contract and then you get lower price for signing this 1 to 3 year contract. There's no upfront cost, but the thing is, you have to pay for it regardless of whether you use it or not. For example, the contract is, for example, you paid for 100 gigabyte of something, but you only use 80 gigabyte. It doesn't matter. You have to pay for the 20 gigabyte that you didn't use. 100 minus 80, 20. You have to pay for that. All right? Therefore, you should only use this when you can predict your workload, right? It only makes sense. For example, I always use 100 gigabyte or this much space in my virtual machine, right? Compute engines. Then I should go for committed use discount because I know how much I'm going to use. This has higher discount rate than SUD, which stands for Sustained Use Discount. However, this requires specific term. Now let's go to Sustained Use Discount, okay? Sustained Use Discount is, if you keep using, it'll be cheaper. Keep using, it'll be cheaper, all right? You don't have to commit a specific term, right? They won't say, oh, 1 year, 1 to 2 years, or whatever it is. It's not like committed use. You don't have to commit to a specific term. There's lower prices for continuous use. Okay, the more you use, the cheaper it is. The more you use, the cheaper it is. Sustained use discount. The more you use, the cheaper it is. It's good for unpredictable usage patterns. When you cannot predict it, use sustained use discount, okay? When you can predict it, use committed use discount. And committed use discount is saying, okay, I promise I'm gonna use this for 1 to 3 years. All right? I hope it's clear when to use sustained use discount and when to use committed use discount. Okay, so now you know how to save money on Google Cloud, don't you? So let's talk about what's SLI. SLI are metrics. So this could be latency. This could be how available it is, right? It could be durability. So, for example, your boss is trying to measure your performance. So he could be looking at how well you deal with customers. He could be looking at your speed. He could be looking at your friendliness. So these are metrics to measure how well something is functioning, right? Metrics. So we use these metrics or SLIs to make our SLOs. Now, SLOs are like goals. They're goals. They're objectives. They're things that we want to meet. For example, I want to make sure the latency is always less than or equal 300 milliseconds. So these could be values or range of values. Or I could say, I want it in between 300 to 400 milliseconds. So just in case you don't know, latency is like how fast the results return to you, right? If you're playing a game and it's taking forever to load, it has high latency. Okay, so something with low latency is better and faster. Then you would use your SLOs and put them all into an SLA, which is a contract that is legally binding. And your contractor is obliged to meet all the service level agreement that you agreed on. Now, having all these will help our system to just be more efficient, and we can measure how well it's doing. So just remember, SLA is basically slew of SLOs. Okay, it's just a bunch of SLOs together that is agreed upon in a contract and signed. Okay, let's talk about Google Customer Care. There are 4 types: Basic, Standard, Enhanced, Premium. Now, Basic is free. Everyone can use it. And it has documentation, billing support, active assist recommendation, giving you insights and recommendation. All right, so for Standard,
It's only English and it's 5 days a week. So if you need other languages, you have to get enhanced or premium, right? Standard is only English. Standard has unlimited tech support. And you can have recommended for workload under development. You can have cloud support API. All right. So for enhanced, it's 24/7 and there's more languages. Okay? Definitely you're paying more, therefore you have faster response time, and they will offer technical support, escalations, and third-party tech support to help resolve your vendor issues. For premium, this is the most expensive one. You get technical account manager, right? And this is something you get if you have critical workloads. And then this technical account manager will help you, right, in these critical workloads. You will also get credit for Google Cloud Boost training because some things you have to pay for, they're not free. And then you have event management service for planning peak events. Let's talk about billing. So if you go to the billing section in Google, this is probably what you're going to see on the left-hand side. And this will be tested in the exam, so do look out for it. They have reports, they have cost table, and they have cost breakdown and budget alerts. So what is reports? Reports are the forecasted total cost. If you want to find out how much you will spend, what are your cost trends, you got to go to reports. If you want to see what are the things driving your costs, causing you to spend a lot of money, you have to go to reports, right? If you want to see your daily costs grouped by selected filters, you can go to reports. How about cost table? What do you do in cost table? Cost table is more for like invoices and stuff like that, right? It's for invoices. So you can see like, okay, these are my invoices for September. Okay, these are my invoices for July. It has a tabular view of your monthly cost for a selected invoice or statement. So in the exam, always remember that if the question talks about invoices and things like that, it's definitely cost table, okay? Invoices. Now, what's cost breakdown? Can you see the logo of cost breakdown? It kind of looks like a waterfall, doesn't it? It looks like a waterfall. The water is flowing down and it's breaking it down. What it has, it has at a glance waterfall view of how much you would have spent at the on-demand price for your Google Cloud usage. How credits saved you money on your invoices. It also tells you how much money you saved. Okay? So, how about budget alerts? Budget alerts are places where you can set your budget. For example, I only want to spend $10 this month on Google Cloud. I don't want to spend more than that on Google Cloud. Then you can click, go to the other third section, and you can even set percentages, an amount, and when to trigger. Do you want to trigger on the actual, or do you want to trigger when you're reaching? Do you want to trigger when you're reaching or when you have already reached the budget? Basically, that's what it's saying. All right. Do you want me to warn you, or do you want to tell me when it actually happens? Okay, that's budget and alerts. So if the exam question asks you, which one gives me alerts? It's budget and alerts. I mean, duh, yeah, you'll definitely get this right. I know for sure. When
when the question asks you, where can I see an overall view, go to reports. When the question asks you, where can I see a waterfall view, it's cost breakdown. Cost breakdown, waterfall view. Cost breakdown, waterfall view. Cost breakdown, waterfall view. All right. And if question asks you, oh, how do I find out where's my invoices per month? I want to find out what's my invoice in September. I want to find out what's my invoice in October. Cost breakdown. Cost breakdown. That's cost breakdown. And if the question asks you, I want a tabular view of my monthly costs and view invoice by month, right? Then it's cost table. All right? Let's talk about data sovereignty and data residency. So data sovereignty is about data is governed by the laws and regulations of the country where it is stored. For example, if I'm storing my data in Switzerland, then my data is subjected to the law of Switzerland. If I'm storing my data in China, then it's subjected to the law of China. If my data is stored in Finland, it's subjected to the law of Finland. It's subjected to the law of where it is stored. Okay? Now, data residency is about the physical location of where the data is stored. Data residency controls allow specifying the geographical location for data storage. For example, XYZ country may mandate that certain data must be stored within the country's borders. You wouldn't want your citizen's passport number and permanent resident card information to be stored outside of the country. That's a security risk. So some countries mandate that my citizens' personal data or personal identifiable information, you should not be able to store outside of our country. IAM, Identity and Access Management, IAM for short, is a service that helps you manage access for your Google Cloud resources. You use it to set policies to prevent misconfiguration. You use it to give roles who can do what. Let's use Sally as an example. So let's say this lady here, she's Sally. Okay, let's say that. And I use IAM to find out, to give Sally roles. I can give Sally roles, which is shown in this picture here, so that I can tell the cloud what Sally is allowed to do here. Okay? So for example, I can give Sally the role of Vertex AI Service Agent. Or I can make her the editor, or I can make her the owner, right? Or maybe I can make her the Cloud Pub self-service. That means if I give her this Vertex AI Service Agent, that means she can only access Vertex AI Service Agent. She can't do the rest of the stuff, right? So this is about controlling who can see what and who can do what. Controlling who can see what and who can do what. Can this person just delete this file? Is he or she allowed to do that? Is this person allowed to go into this project or this resource? Yeah, you can grant all the access in IAM. All right, what is BeyondCorp? BeyondCorp started out as Google's own internal initiative of implementing a zero trust security model. But then they published it, and it's something that you can follow using the BeyondCorp Enterprise service in Google Cloud. So remember, BeyondCorp is different from BeyondCorp Enterprise. BeyondCorp Enterprise is a user interface designed to help you meet the BeyondCorp. All right? So what's the idea of BeyondCorp? BeyondCorp is trust no one, verify everything. It's a kind of mindset. Think of it as a mindset that people have, right? Do I just let anybody come in my house, or do I just first check who they are, right? You would check who they are. So it's about trusting no one. Data governance. What is data governance? You know how in human countries we have government, and government will tell you, you can't do this, you can't do that. And if you murder someone, you need to go to jail. Yeah, because governments
governance is very important to make sure a society runs in order, right? So the same thing for data. Data has to be governed too. You can't just let the data run crazy and do anything. You can have the same person with different birthdays and different database. You can't have that kind of thing happen. You can't let the data run crazy. And then you can't have like someone's birthday or name spelled wrongly and things like that, right? So we should have rules surrounding data governance. So what is data governance? Data governance is a framework, policies and processes and standards that ensure the proper management, quality and security of an organization's data. So this also means that you should ensure the consistency of data, make sure data doesn't contradict itself. So for example, the same person should not have different birth dates in different database, right? That does not make sense. Then the other thing is accuracy, right? You shouldn't have people's birth date wrongly, or you shouldn't be spelling people's name wrongly. Data should be accurate and data should be reliable. All right. So data governance, imagine data governance as like a group of people here governing and discussing how we should govern data. Also, data is subjected to law. Yes, data has to be compliant with law. For example, in Europe, right, they have very strong laws regarding privacy. So, for example, I have the right to be forgotten in Europe. I have the right to be forgotten. That means if I ask you, hey, please remove my address, birthday, name in your database, you have to do that for me in Europe, right? So your data of your company has to be compliant with the law, else you're gonna be in trouble. So we need, there are also many other standards and that you have to be compliant with. So how do we manage all of that? It can go crazy, right? We can manage that with Google Cloud Dataplex. Google Cloud Dataplex is a data management and governance platform. All right. Then the other thing we can use to manage data is use identity and access management, IAM, to control who has access to which resource. You know, just like humans, we have Africans, Asians, you know, Westerners, different type of people, right? There's different type of data too. For structured data, it has rows and columns. It's like SQL and relational database. So it's very structured. You have to follow the structure. What kind of services? You can use Spanner, Cloud SQL. These are all for structured data. All right? Structured data. Big table, Firestore, therefore semi-structured data. Semi-structured data falls in between structured data and unstructured data. They're somewhat in between, all right? So they kind of have structure and they kind of don't have structure. They're kind of messy, but they're kind of tidy too, something like that. So some structure like tags or markers like JSON and XML, these are considered semi-structured data. All right. Now in Firestore, of course, you can store structured data. You can store a table inside of Firestore, which is the structured data. But the thing is, it's more designed for semi-structured data. Okay. Now moving on to unstructured data. So they have no predefined format. It could be images, videos, audios, emails, Word, documents. So they're not tables, and they could be your favorite MP3 file, they could be your favorite movie, they could be your favorite picture of your dog or your favorite picture of your family. These you put in cloud storage of Google. Okay?
Google Cloud Storage is designed for unstructured data. You can put like video there, you can put your MP3 there, you can put your favorite music there, all kind of unstructured stuff, right? They don't have defined format. They don't have a defined format. All right, let's talk about Apigee. The first tree word is API. API. What is API? API stands for Application Programming Interface. It's a set of rules and protocols that allows different software applications to communicate with each other. All right, that might sound a bit complicated, but I promise I'll explain this in a simple manner. Imagine API as two friends in a party. These two friends in a party want to talk with each other. This friend might be asking the other friend, "What did you eat yesterday?" The other friend could reply, "Pizza. I ate pizza yesterday." They're sharing data and communicating with each other. Now, software components will also communicate with each other like friends in a party. They want to chat and share information. For example, there could be one website, and this website is sending a request to a weather API. Or this website could be sending a request to an API to get cute pictures of cat. That could be two software system component talking to each other. Now, another analogy to help you understand is a waiter analogy. For example, you are a customer at a restaurant and you want to order your favorite strawberry milkshake, for example. You ask the waiter to go to the kitchen to get the strawberry milkshake, okay? So imagine the food is the data. So the waiter goes to the kitchen, get your strawberry milkshake, sends it back to you, right? So this is what we call an API request, and then you receive the request, right? So the data travels from the kitchen to you, and you request the data from the kitchen, which is your milkshake. So in terms of API, there are producers and consumers. Producers and consumer. The cook who is making your milkshake is the producer, while you who are drinking the milkshake is the consumer, right? And so Apigee is like a food bazaar marketplace, but for the consumers and the producers to come together and they can buy each other's food. For example, there's one stall selling milkshake, another stall selling pizza, another stall selling chicken nuggets. I'm already getting hungry saying all this. But yeah, so it's like a marketplace for API. It helps you make your API more discoverable. It helps you build, manage, and secure your APIs. All right? So consumers, they want to know how to use your API. So that's also what Apigee does. It provides good documentation to how to use your API. Let me show you what an API is. This is an API that gets cute pictures of cats. All right? So this URL is a request. And usually, if you have to pay for the API, there's a key behind this URL that you have to put in order for this response to even come out. Now, this response has an ID, key value pairs. This is a key, this is the value, and URL, which is the cat PNG, then the width and the height of the photo. And if you look, this is the photo of the cat that I got. So this is an example of a cat API. When I'm sending a request this URL as the consumer, the producer sends me this image of a cat back. So this image is like the milkshake that I ordered from the kitchen, and the producer sends it back. There are also other APIs that you must pay for example, weather API, right? So API is a business. It can be a business, right? See, this company is charging for
weather APIs.
Okay, so let's talk about the machine learning options on Google Cloud. First of all, you have the BigQuery. This BigQuery is good for good for people who use SQL. All right. BigQuery is very, very dynamic. It can do a lot of things. It's a data warehouse. You can use SQL on it. You can query it. You can also use SQL to do machine learning on it. So it's very, very dynamic. And most data analysts, they will know how to use SQL. And what type of SQL it is, it's all quite similar to each other. Then the easiest form of it is pre-trained APIs. I showed you the cat API where it generates a random image of a cat. Pre-trained APIs is somewhat similar to that. And it's less customizable, but faster. Faster to implement because Google did everything. You just use what Google already made. So what kind of APIs are there? Of course, this is not all the APIs. I didn't list all of them. One is Cloud Vision. Okay, Cloud Vision is replicating the human function of seeing for image analysis and recognition. So when you see an image and you see a cow on it, you know there's a cow on it, right? So that's a robot replicating the human function of seeing things and identifying what are in the image and things like that. All right. Next, Cloud Natural Language API. Now, natural language is, what is it? It's conversational. It's a robot replicating humans' conversational ability and humans' emotional ability. So this includes sentiment analysis. What is sentiment analysis? Sentiment analysis is a robot trying to find out whether you feel unhappy or happy in this sentence or neutral. But it's not right all the time because at the end of the day, it's a robot. And currently, sentiment analysis is still not a developed science and robots often get it wrong. Okay? Just to let you know. Cloud speech to text and text to speech APIs. For example, when you're typing something, right, and it converts it to speech, that's text to speech. Speech to text is if you're talking and then it transcribes. It's like your note taker. It helps you take minutes. Sometimes people use this to take minutes, right? So people are talking, person A, person B is talking, and then the Cloud API converts their conversation into text so that a human doesn't have to take minutes. Well, this is just one of the many, many kind of applications that is possible with Cloud speech to text. All right. The other option is AutoML. It's a no-code using Vertex AI. Then the last option is the hardest, which you custom your training. Now, sometimes what Google offers you is not enough, so you have to custom it so that it's specific to you, right? Specific to your industry. So if the exam asks you questions like, okay, I want to do machine learning. I want to do machine learning on Google Cloud. But here's the thing. I don't have amazing data scientists. I just have data analysts, right? So what's the option? The option is BigQuery. Pick BigQuery. Other possible exam questions are, for example, my staff has absolutely no data science knowledge, and I don't have time to train my own data. Then don't pick custom training. Custom training, it takes time. What's the fastest is pre-trained API. Then this should be the answer because it's easy and it's fast. Google did all the training already and they tested it. They make sure it's somewhat reliable or more than reliable. Then they publish it. So you're using something that's already built upon. Hence, it's faster and easier. All right. Okay, so let's talk about the AI tools in Google. There's the Contact Center AI. So Contact Center AI it gives you insight to customer, like the sentiment and topics. For example, a customer calls you and say, I'm upset with this TV. It broke immediately. Like, I just bought it and it just broke. Yeah. So it'll give you insights that this customer is angry. All right. And it also, you can like create this robot customer service person, right? Because maybe you can't afford to hire so many customer agents. So you can take advantage of Google Contact Center AI and create robot customer agent. So it uses generative AI powered contact center experience, and it also has like agent assist, a robot that assists the call, basically a robot doing that. Okay, so this is about all you need to know. You just need to know generally for the exam. All right. The other AI tool is document AI. It takes unstructured data from documents and transform it into structured data, right? So all your receipt, your driver's license, it can take that and put it in a table. For example, I can take all the receipts that you have and then take out the item and amount. I can just extract the item and amount. Can you imagine how convenient this would be if I'm an accountant or I'm a company where employees can claim receipts of maybe what they ate overseas. Okay, they took a picture of their receipt, they sent it back, and they are supposed to claim it. I can just use document AI to not keep hard copies of the receipt. I'll just have a soft copy of the receipt and then transform that into a table so that I can like calculate. That's just one example of the use case. There could be many, many use cases. Okay? Now, the other concept you have to understand is what is virtual machine. Virtual machine in a very simplistic way is like a computer inside a computer, right? Used to be one server only do one thing. So let's pretend this is a server. It only can do one thing. But what happened with VM is that we found a way to put a machine inside a machine so that things are compartmentalized. Okay? It's a software program that emulates physical computers. They allow you to run multiple operating systems on a single physical machine. So virtual machine is kind of like computers, but you can have multiple computers inside a computer. Kind of like that. And these computers, these virtual machines, right, they run independently from each other. So they don't really affect each other. And yeah, so therefore it's good for isolating things and testing different software in different environments. And the other interesting thing about VM is it can emulate the hardware components like CPU, memory, and storage to make it be like a computer inside a computer, basically. And who is the one who's making this possible? It's the hypervisor, right? A hypervisor is a software that manages VM. It helps to allocate resource and ensure each VM runs smoothly, right? There are two types, which this will not be tested, so I will not go into details. I only cover things that will be tested, but this understanding will help you for the other part which will be tested, which is block storage for VMs. So there are two types, and do know the difference. There are local SSD and persistent disk. So what is the major difference? Local SSD is physically attached to the VM. It's physically attached. So when the VM dies, the local SSD dies with the VM and the data is lost. So when you want to use local SSD, right, you should only use it for temporary storage. But because it's physically connected to the VM, it's faster than the persistent disk, okay? And for persistent disk, it's not
physically connected to the VM. It's network connected, okay? So when the VM RIP dies or is terminated, the persistent disk, the information in the persistent disk persists. That's why it's called persistent disk, because you can put things that are not for temporary use. If it's for temporary use, use local SSD. Okay. When do you use persistent disk? Is when you need extra storage in your VM. Then you attach it online. So by default, each VM will already have one persistent disk. But let's say you need more, you can buy one from Google. All right. Compute engine are for virtual machines. So when you want to set up an instance of a virtual machine, you use compute engine. And for compute engine, there's two options that you need to know for the exam. It's spot VM and preemptive VM. So the thing with preemptive VM, it expires after 24 hours. Yeah, it can be terminated anytime after 24 hours or sooner if Google needs the resource. That's preemptive VM. So why would you use it? Why would I use something that expires in 24 hours? Well, you would use it to save money, right? For fault-tolerant and flexible workloads. For example, if you're doing batch processing, if the VM is suddenly gone, right, it wouldn't really affect you because maybe you're only batching every week or whatever it is. It wouldn't affect you. It doesn't have to be on all the time. So therefore, it's fault-tolerant. Then the other option is spot VM. So these two are both like economical option when you want to save money for fault-tolerant workloads so they can afford to stop for a while. The spot VM is ideal for things like batch processing, data analysis, or testing. Okay, this is what it's ideal for. And they are very cheap compared to regular VM. Cheaper than regular VM. But it's not reliable because Google can terminate spot VM anytime, right? If the resource is needed elsewhere. So you should only use spot VM and preemptive VM for workloads that are not time sensitive and can handle interruptions. Only for workloads that are not time sensitive. All right? Now the benefits of compute engine, it can auto scale, increase, decrease, that's auto scale, load balance, so it can move the traffic around, distribute the traffic, and you can pick TPU if you're doing things with machine learning. This hardware is designed by Google in-house, and it's something they're very proud of, hence they like to test it in the exam. It's a hardware that's good for machine learning. So it looks like this. It's a piece of hardware that is designed for machine learning. If you're doing machine learning, pick TPU. There's also GPUs. You can also have standard VM, more expensive. This compute engine is an infrastructure as a service. So you're responsible for all the configuration and everything inside here. We're responsible for a lot of stuff compared to PaaS, platform as a service, compared to SaaS. Right? It's more work. So you only pick compute engine when you have the IT people, right? You can choose the predefined machine type, size, and configuration for your compute engine. It's customizable. Let's say if you want really, really large VM, really, really powerful VM, then it's more expensive, right? The smaller the size, the cheaper it is. And depending on what type it is, the prices change, right? What is Vertex AI? Vertex AI is a machine learning platform where you can develop and deploy, manage ML models, okay? So it's the whole cycle, right? You develop it, you deploy it. Deploy it means you make it available for people to use or yourself to use. Now let's go down to BigQuery. BigQuery is very interesting. It's serverless. Means you don't have to care about the servers. It doesn't mean there's no server. Everything has server here. BigQuery it's like a data warehouse. So think of, you know how you store boxes and deliveries in a warehouse? Well, think of all these boxes as data, right? BigQuery is a place to store data in a warehouse. We need a place to store data too, just like parcels and deliveries need a place to be stored. The interesting thing about BigQuery is it does storage and also does analytics. And it also can do machine learning, so it can do a lot. You can use it for machine learning, search, geospatial analysis, and business intelligence. Okay? You can work with both structured and unstructured data. You can use SQL on it. What's SQL? SQL is basically something like this, right? I can select something from a table and sum it up and show this sum as total sales. And from this table, right? You don't need this for the exam, but just in case, just to give you the good big picture so that you understand stuff, but you really don't need this for the exam. All right, you just I just thought it's better to show you what SQL is and not just have you memorize blindly. So we use SQL to perform complex queries and analytics on large data sets, leveraging its powerful SQL capabilities. So this is querying. This is me selecting from the table, and this is another look at BigQuery. The other storage is cloud storage. Cloud storage uses buckets, right? So they could be buckets and buckets. You know how you store water in buckets? Just think the water is data, right? You're storing data in buckets, right? And inside the buckets, you could have folders. Inside the folders, you could have subfolders, all right? So cloud storage is just like for storing things and storing objects and unstructured data, okay? You can store like, what's unstructured data? Unstructured data is like images, videos, pictures, your favorite, music, your favorite pop music, your favorite country music. Those are unstructured data. Now, for cloud storage, they have this 4 storage class, which will be tested in the exam. Alert, alert! The first is standard. Standard is most expensive, and you put things there when you use it frequently. Nearline are things you use once a month. Cold line are things you use once 90 days. Archive are things you use once a year, and it's cheaper, right? So you have to strategize. By the way, this kind of cold line, standard, nearline, archive, this concept is in Azure Blob Storage and AWS as well, this concept. So once you learn it, you understand it, you'll be good to go for other cloud as well. They have different naming, but the concept is the same. You have to know where to put your stuff. If you don't use something frequently, you should put it in an archive, else you'll spend a lot of money. So you're like, oh, but what if it's such a hassle for me to move things around? Then there is an auto class function. So it moves things around for you if you find it a hassle. For example, if I use a lot of cat photo this month, standard, So I need to access cat photos frequently. I'll use standard. But suddenly I don't like cats anymore. I like dogs. So maybe AutoClass will help me move the cats to archive and the dogs to standard. That's kind of what AutoClass do. Then it saves money, That's the thing. So when you think of the storage classes, think of your fridge. For example, your meat, right? In order to preserve your meat, you'll put it in the freezer to freeze it up, to preserve it so that it doesn't, rot, because you won't use it that often. So think of that as cold line. It's cold in the freezer. It's very cold. That's things used once in 90 days, all right? So once you're ready to use your meat or eat your meat, you're gonna put it down to the chiller to defrost it, right? So think of the chiller as standard and nearline. Those are the chiller. You're ready to eat it. So it's things that you frequently use. So you can notice standard is frequently used and nearline is 30. So 30 times 390. So 30, 90, 1 year. 30, 90, 365. That's how you remember it. And this will definitely be tested in the exam. What is looker? Look. Let's look at graphs. Let's look at bar charts. Let's look at pie charts. Looker. Look. It's for data visualization, business intelligence, and graphs. It's a very visual tool. And it's the easiest to remember for the exam. So let me give you an example of how I can use Looker in Google. For example, I'm a company that stores transactional data in BigQuery. For example, I sell chocolate milk, right? So I'll store all my sales in BigQuery. Then I can take the information from BigQuery, send it to Looker, and Looker will do a data visualization to help me see the reports that analyze customer buying patterns over time. So this is good for management to see the data visualizations. Let's talk about Bigtable. Bigtable is designed for IoT. So for example, I want to collect the temperature every single second. Then I would have a lot of data, right? So it has to be able to handle a lot of data. So large amount of data. It can be even terabytes or even petabytes of data. Huge amount of data. It's great for large analytical and operational workloads. It's great for time series data like temperature for the second, temperature for the next second, temperature for the next second. It's primarily designed for semi-structured data, no SQL. So what is IoT? Let me explain what is IoT. IoT stands for Internet of Things. Internet of Things. Now, Internet of Things is like random objects communicating with each other. For example, your cup could be sending signals to your computer in an app to tell you what's the temperature of your coffee, right? What's the temperature of your chocolate? Or it could be your aircon connected to your cell phone, so you can turn on your aircon even before you go home, so that your room is all cool when you're back home. It could be your piano that could talk to the internet and send information to the internet, right? It could also be your car, right? Car connected to the internet. So all these random objects can send information to the cloud, and then maybe your phone gets the information from the cloud and service and display that information to you. Let's talk about Spanner. Spanner is great for real-time gaming. It speaks SQL. It's a structured data. It has zero downtime and ensures data consistency and integrity. It scales horizontally. There's global distribution and it auto-replicates. So if I have different players in different countries, right? It's able to handle that because its globally distribution is powerful. Now, what's SQL is something like this, all right? And to learn more about Spanner, there's actually a lab that you can do, which is get started with gaming on Cloud Spanner, where you can find it. It's Cloud Skills Boost. Search cloudskillsboost.google
then you'll be able to find a lot of courses. I want to build a website. Would you build a website with me? What do I use to build a website? Do you want to build a website? Yes, I want to build a website. You use App Engine to build your website, and this is platform as a service. So you don't have to worry about the infrastructure, right? You can build your application with your selected coding language. You know, human, we have languages like, for example, Korean, Japanese, English, French, Italian, Spanish. Computers also have language of communications. For example, Java, Python, PHP, Go, Ruby, C#. These are languages where you can build websites. And then you have to code it, but then they will manage the rest. So you code, you put it in App Engine, then it will be deployed now. Yeah. The good part of App Engine is that you can host different versions of website. For example, I'm making some changes on this website, but I don't want the users to see all my changes. And when I make changes, there could be problems, right? There could be downtime. So downtime is like users can't touch it, users can't use it. So what would happen is that I give the user one version, they're using it, then I work on the other version. Right. And so when the other version is ready, I'll push that version up so that they use the new version, and I'll take the old version down. So this is a way to reduce downtime and improve the user experience. All right. Moving on to container as a service. Container as a service. These are the two container as a service. Cloud Run, like this boy is running, and Google Kubernetes Engine. Let's start with Cloud Run. Now in Cloud Run, you have three options. First, you can deploy one revision from an existing container image. So you upload an image that you already created. Then the second option is you continuously deploy from a repository like GitHub. Third option is you use Cloud Run function. And this one, Cloud Run function, is function as a service. Okay, not container as a service. This one is function as a service. So what is function as a service? Function as a service is small pieces of code, right? This is a small piece of code. Once something happens, like there's a trigger, it will trigger this small piece of code to run. For example, the trigger can be anything like I add something in my Cloud SQL, or I delete something from my spanner. Those are all potential triggers, right? If I delete something or I add something, these are all potential triggers. For example, I can have a pub sub trigger, I can have a cloud storage trigger, I can have a Firestore trigger, I can have other event target trigger, right? For adding and deleting. And this, when I, for example, add something to my pub sub or do something there in pub sub, it triggers this code, and this code is doing something, right? It's an event, all right? This Cloud Run function is previously known as Cloud Functions, but now they put it inside this Cloud Run thing. So it's became merged together. So Cloud Run Functions. All right. For Cloud Run Functions, it's serverless. It doesn't mean there's no server. It just means you don't have to worry about the server. It's a function as a service. You can even have multi-event trigger management on functions. So to help you understand trigger, for example, you're allergic to flowers. So when you smell the flower is the trigger, and it triggers you to sneeze, okay? This smelling the flower is an event, is a trigger, then it leads to an event, which is you sneezing, which is an action, a verb. A verb happens, right? So this This code is the verb that's happening. A small pieces of code that does something. The verb that happens from the trigger. Am I right? So that's Cloud Run functions. Now what's Cloud Run? Cloud Run is container as a service. When you're dealing with images, Docker Hub, right? You're dealing with containers. That's what you're dealing with. You can use any language and run your containerized application without managing any infrastructure. It does the load balancing for you, and it deploys the website for you. So you can run front-end, back-end services, batch jobs, host LLMs, and queue processing workloads. Okay. So this is container as a service. Cloud Run is container as a service. Okay, because you're using Docker and Artifact Registry. Now the other container as a service is Google Kubernetes Engine. Google Kubernetes Engine. All right. Now, in order to understand Google Kubernetes Engine, you have to understand containers. What is containers? Containers is like a box that holds everything an application needs to run. Imagine it like a lunchbox for software. Lunchbox for software. Container is like a lunchbox for software. You have your chopsticks, you have your spoon, you have your fork, you have your food, right? In a lunchbox. So, inside a container, there's code, which is the heart of the application, the instructions the computer should follow. And there's the dependencies, which are special tools and helpers the app relies on. And there are the settings, which are the configuration files that tell the app how to behave. So that's a container. Container is like a box that holds everything an application needs to run, so that there's no problem where it works on your computer but it doesn't work on my computer because you're using a different version as me, right? The container will tell me which version to use, so everybody uses the same version. All right. This is not suited for legacy system. You will need to refactor a lot, so it's not possible. It enables rapid application deployment and testing, fully automated cluster lifecycle management, pod and cluster auto-scaling. Now, for container, a container is a cloud neutral, right? So you can take this container, take this image, and put it into different, for example, I can take an image from Azure and use it in Google. I can take an image in Google and use it in AWS. So it's cloud neutral in that sense. All right, so let's now talk about security. Security in the cloud. How do we protect ourselves and be secure on the cloud? First, there's Security Command Center, and there's Google Cloud Armor. Google Cloud Armor is for DDoS attack and application attacks like cross-site scripting, XSS, and SQL injection. So what is DDoS attack? It's like this evil guy, okay? He gets multiple machines, and he manipulates these machines. These machines are like his puppets. He gets his puppets to attack your server with many requests. So basically, it's like maybe your server can only take 100 people, right? So what this bad guy will do, he will overload your server with so many requests that your server stops to work and the service is no longer available, right? So you could, like, for example, websites, right? If 7 billion people use a website, right, it could break down. So what this bad guy is doing is it's just sending many requests until the server cannot take it, so the server shuts down. All right. Now it's Security Command Center. Security Command Center is like there's vulnerability dashboard, and it helps you to identify vulnerability and threat reporting service. It can also assess the virtual machines and containers in your cloud environment for vulnerabilities. Vulnerabilities are like weakness that the attacker can take advantage of and get into your system and do bad stuff. Those are vulnerability. So there's the premium and enterprise tier of Security Command Center include the security posture service, right? So if you pay more money, you can get the security posture service. It also can scan for misconfiguration. Oh, you really don't want to do misconfiguration. Then it can manage compliance with industry standards. So if the exam question talks about DDoS attack, which is denial of service attack, because the web page gets overloaded with requests that it doesn't work anymore, so it's a denial of service attack. Then you should pick Cloud Armor, Google Cloud Armor. But if the exam question is talking about detecting vulnerabilities and threats and having a vulnerability dashboard, Security Command Center is the correct answer. All right, let's talk about data, capturing data, processing data, store and analyze data. So think of data as this apple, right? I'm picking apples. When I'm picking apples, I'm capturing data. Like this auntie, she's picking apples, right? She's capturing the data. After you capture the data, you have to process the data. So think of processing the data as washing the apple, chopping the apple into pieces so that you can store it in the fridge. Store and analyze it. You can analyze the apple and see how much sugar there is, how much vitamin C there is, things like that. Store and analyze it. Okay? Or the other way is you can think of data as water, right? You're capturing the water, right? You gather all the water, then you put it in a pipeline and the water moves in the pipeline and moves, and now you have to process the water. You need to clean the water. So maybe you do like reverse osmosis, or you use ultraviolet rays to kill the bacteria inside. You filter it, you clean the water, make sure it's usable. Then after that, the water flows and it's stored as ice cube in the fridge. That's another way to look at data, right? And so we need to capture data. So this is the time we're capturing data. What do we use to capture data? We can use pub/sub. Now, pub/sub, you can just think of it as YouTube, right? Think of it as YouTube, right? A YouTuber is a publisher, and a YouTuber has subscribers like you. So the subscribers will, whenever the YouTuber publishes any videos, they will receive an alert and then they can watch the video. All right? So think of that, pub and sub. Pub stands for publisher, sub stands for subscriber. So it's a messaging service, right? Publisher sends a message, subscriber sees it. The other subscriber, which is subscribed to this service, sees the messages that the publisher sent. Okay? So this is a way of capturing data. Okay? Imagine this message is data. Now, after the data flows through the pipeline, it has to be processed, right? We don't want things to be messy. We want it to be clean and tidy so that we can store it. We don't want to store messy things. Afterwards, we use Cloud Data Flow to kind of do the ETL, which is extract, transform, load. It executes Apache Beam pipelines that ingest data into data warehouse such as BigQuery, right? its job is to ingest the data to BigQuery or other place. So the job of data flow is take from here and bring to here, take from here and bring to here. So it reads from one or more sources and transform the data and write the data to the destination. You can do batch streaming, batch and streaming data processing. So what's batch? Batch is like I take 8 apples, or I take some apples at a time, maybe like 20 apples or 30 apples. I take 30 apples at a time, and I will carry those 30 apples and bring it back home to be washed. That's batch processing. I take a group of them and wash it. But stream processing is I take one apple, bring it to wash, store it. I take one apple, bring it to wash, store it. I do one at a time. So you typically stream data processing is used with like time series things. For example, the temperature at 8 a.m. was like 20 Celsius. Then I'll send that in, right? I can't wait to batch process it. Usually. Okay, usually that kind of stuff, it would be streaming data processing because I need to know the temperature, right? I want to know the temperature 1 second ago right now. Then it has to stream, right? If I want to know the temperature 5 minutes ago, it gotta stream because I need real-time data, so it has to stream. I cannot wait for you to gather like maybe like 5 years of weather temperature and then bring it over, or like usually it's not 5 years, shorter, maybe like 1 month send, 1 month send. All right. Now, Cloud Data Proc is something similar to Cloud Data Flow. But the thing is, Cloud Data Proc uses Hadoop and Spark. Okay? Cloud Data Flow uses Apache Beam pipeline. That's the difference. So in the exam, if the question asks Hadoop and Spark data processing, pick Cloud Data Proc. Okay? A good way to remember is that this Hadoop has a P and Data Proc has a P too. So this two comes together. Okay? Basically, both Cloud Data Proc and Cloud Data Flow does ETL, right? But they just use kind of like a different technology. Cloud Data Proc uses Hadoop/Spark, while Cloud Data Flow uses Apache Beam pipelines. Okay, so Cloud Data Flow takes from here, brings to BigQuery. Okay, and what does BigQuery does? BigQuery does storage and analysis. It's a data warehouse. Think of this, right? Think of data as boxes, and you're keeping it somewhere, keeping it in a warehouse. Okay, and then this guy is gonna analyze each of the boxes. All right. So this is the typical flow. From an external system, you'll go to pub sub, a messaging service, publisher, subscriber. Then you'll go to data flow, right? Data flow or data proc, right? Then you'll go to BigQuery and Looker. What's Looker? The first 4 words, look. It lets you know that something very visual, right? So it's for data visualization. So you can see pie charts, graph. You can customize whatever you want to see. You can just click on it. It's quite easy to use. Let's do a recap of what we learned. First of all, block storage. For block storage, there's persistent disk and local SSD. Local SSD is for temporary files, while persistent disk is for non-temporary files. It is not physically attached to the VM like local SSD. What is VM? VM is like a computer inside a computer. Compute engine lets you pick your VM, the machine type, the size, and configuration. Google Kubernetes Engine is a container as a service, and it helps to orchestrate, manage, scale containerized application on Kubernetes. Google Cloud Armor helps to protect you from DDoS attack. App Engine helps you build website. Apogee helps you manage your application and manage your APIs and make your APIs more discoverable. And what is an API? API is like two software components, like friends at a party. They want to chat and share data. It is also like a waiter who goes to the kitchen, which is like one software component, and goes back and brings the data information to the consumer, the customer. The food is like the data, and the food travels from one software component to another software component. We also talked about Looker, which is a data visualization platform. It has pie charts, bar charts, and anything you can think of. We talked about Security Command Center, which helps to detect vulnerability and threat. We talked about the AI tools, where there is Document AI. Document AI basically takes your documents such as receipt, driver license, and forms, take those unstructured data and put it into a table, right, which is structured data. They also have Contact Center AI, which uses generative AI-powered contact center. So you can use AI to assist your human agents, or you can use robot agents to assist your humans. We also talked about machine learning options, which is BigQuery, great for data analysts who know SQL, pre-trained APIs, which is good when you don't have your data to train, and is less customizable but faster and easier. Auto ML, which you can use Vertex AI and no code. Custom training, you need to code on your own, and you need data scientists to do this. We also talked about the type of migration, which is rehost, lift and shift, minimal time and effort, but minimal business value, and you benefit very little from the cloud. There's also replatform, refactor, reimagine, rip and replace. We also talked about the different type of service. There's infrastructure as a service, there's platform as a service, there's software as a service, there's container as a service, there's function as a service. These are the different type of service. With infrastructure as a service being the service that you're most responsible for, and software as a service as being a service that you're least responsible for things, and you need less technical skills because you don't need to code at all for software as a system. We also talked about the different types of data. We have structured data, semi-structured data, unstructured data. Spanner is good for structured data. Cloud SQL is good for structured data. Bigtable, Firestore is good for semi-structured data. Cloud storage is good for unstructured data, like your favorite music, your favorite movie. We also talked about data residency, which means a country might say, I don't want you to put my citizen's permanent resident card in another country, because that would be a security compromise. That would be dangerous. Data sovereignty is that data is governed by the laws and regulations of a country where it is stored. For security model, you have privilege access, which is dangerous, means basically super user. This privilege means you only are given access that you need for your job. Zero trust architecture means you authenticate every device, you trust nobody. We also talked about the need for data governance, a framework of policies and processes and standards that ensure proper management, quality, and security of an organization's data. We also talk about the idea of Beyond Corp, which is a trust no one, verify everything. It's Google's implementation of the zero trust security model. We also talked about the IAM. IAM is used to set policies to prevent misconfiguration. It's about what kind of access am I gonna give Sally? Am I gonna allow her to be a Vertex AI service agent, or I'm gonna allow her to go into Cloud SQL, or am I gonna allow her to use Spanner? I can give her different roles and different access based on what she needs, and I should only give her the minimal level of privileges, least privilege. We also talked about BigQuery, which is great for your data analysts who are familiar with SQL. It does storage, it also does analytics, and it also does machine learning. It's very dynamic, and it's an absolutely unique offering by Google. We talked about Bigtable, which is great for IoT, because with IoT, you have all these sensors sending data constantly. You will have very, very large volume of data, terabytes or even petabytes of data. We talked about file store, which is good for sharing files. It's great for mobile and games. It's like a network file storage system, a file-level storage architecture that allows multiple users and devices to access and store file over the network. And it's almost real-time. Means if I add a file inside, you'll be able to see it almost immediately. We also talked about Vertex AI, which is a unified platform for developing, deploying, and managing ML models. It's the full thing. We also talked about container as a service, which is Cloud Run, and function as a service, which is Cloud Run Functions. And how Cloud Run Functions work is that there's a trigger that runs small pieces of code, and this small pieces of code does something. All right? We also talk about the concept of regions and zones. Zones are inside regions. For example, Melbourne, Australia, APAC is a region, and Australia Southeast 2A, Australia Southeast 2B, Australia Southeast 2C are the zones, and these 3 zones are inside the region of Melbourne. Ladies and gentlemen, we have reached our final destination. Thank you for joining me on this cloud journey. I look forward to seeing you again on our next adventure. Safe travels!
Like, comment, and subscribe.